I hope by undertaking research focusing in sustainable development, we will be able to create change as part of a continuous improvement process.
Recognize the work of healthcare and life science scientists and organizations who contribute to innovative healthcare solutions.
I hope participants will continue their efforts in showcasing their hard work, find a product, and meet potential partners.
We are growing too fast. We walk fast. We eat fast. Though we have 24 hours in a day, somehow we share the same feelings. Time is passing so fast. We don't have enough time for ourselves until busy is the new norm in our life. But if you can turn back the clock, what good shall you do today? Let's put life back. We need the past to enlighten the present and the future. We need education. Through education, it reconnects you with the purpose of life. Reconnect with family and people. Reconnect with nature and habitat. Reconnect with unity and harmony. Reconnect with spirituality and peace.
اقرأ باسم ربك الذي خلق.
Reconnect with good health and well-being. To create balance, UITM nurtures Buddhi in education and embraced it as values in life. A concept of social relationships. A philosophy and culture of politeness, reasoning and wisdom among Malaysians. UITM upholds Buddhi for sustainable community. Education reconnects you with the universe. Reconnect your world with UITM.
In the quest to search for knowledge and insights, diving deep for ideas to gain prominence, be they the scientists, teachers, accountants, entrepreneurs, engineers, artists, managers, lifesavers, mothers and fathers. Let us be a trusted companion, your preferred high-flying institution, as we achieve excellence holistically. Because we believe in nurturing our future talents, we endure sowing the seeds for a sustainable tomorrow. We harness your capabilities. We take steps and stances to broaden our knowledge and experience. We want to be the champion to uphold mankind's universal values, to encourage a deeper understanding of sustainability. We dare to be different. We instill values. We cherish the diversity, where science and arts complement each other. We go boldly. Set the scene. Steal the show. Think out of the box and set our sights. Walk far and wide. We dedicate ourselves to all our passion, to nurture the courage in all of us. We lead.
UCSI University has come a long way since 1986 as a Praxis University. Today, UCSI is ranked at the top 300 university in the world, rising steadily every year, reaching the rank of 284 in the year 2023. In the same year, UCSI became the only university in the world to receive the QS Recognition for Improvement Award, having improved by the most ranks in average. UCSI programs are ranked among the world's best in music and performing arts, hospitality, engineering, business management, art and design, social sciences, and medicine. As a Praxis University, our students are exposed to a wide learning experience. Thousands of corporate partners offer internship and work exposure to UCSI every year, enabling our students to apply what they learned in the classrooms to be practiced at the workplace. They give the students opportunities to work and learn. This resulted in our graduates attaining 100% employability score in all our programs. One of the hallmarks of being a UCSI student is the research attachment opportunity at world-leading universities at the undergraduate level, enabling them to publicize remarkable papers at the world stage. opportunity to study abroad, whether for a year or two, or for a short term of a few months, prepare our students the global outlook that the world needs today. Preparing as leaders for tomorrow. The students are exposed to real leaders today, from academics and economics, to social concern and topics on sustainability. Our students are set for the challenges today and the future. UCSI offers the largest fields of study in a Malaysian private university, whether in championing healthcare and medicine and pharmacy, impacting research and discoveries in applied sciences, applying skills and intelligence in engineering, influencing communication in social sciences, igniting the passion and creativity in arts and design, setting the global pace in hospitality and tourism, transforming architecture and built environment, celebrating with music and performance, excelling in the changing demand of the business world, or digitizing the world in computing and innovation. UCSI continues to serve with scholarships, producing tens of thousands of practitioners and young leaders from more than 110 nationalities. Beside its current main campus in Kuala Lumpur, and other campuses in Kuching and Spring Hill, UCSI has earmarked its Kuala Lumpur campus to expand as an edu city with 35,000 student capacity with various state-of-the-art facilities. Our students are the real stars of UCSI. They achieve and excel in the national and international stage. Driven with the passion to contribute, they prove their quality, participating in various events and attaining many successes. UCSI enables them to make the mark for themselves, build their own reputation, and create a brand for themselves to face the exciting world ahead of them. Every year, our medical students advance their undergraduate medical research at the Harvard Medical School. Others made the engineering impact at the Imperial College London, at Queensland, Australia, and Tsinghua, China. While some set their pharmaceutical legacy at University of Chicago and British Columbia. These are some of our students who have benefited from our Star Trek to the world's best universities. The world is changing, and they are at the forefront. The needs are evolving, we continuously confront. UCSI, a Praxis University.
Ladies and gentlemen, welcome to our knowledge sharing session. We hope you'll enjoy the next webinar. Thank you for joining us.
Assalamualaikum warahmatullahi wabarakatuh, and very good morning to everybody. My name is Muhammad Hafiz bin Muhammad. I'm from Nano Electronic Center, School of Electrical Engineering, College of Engineering, University Technology Mara Shah Alam, Selangor, Malaysia. Today I would like to share with you on this topic. The title of my presentation is Metal Oxide Nanostructures as Sustainable Nanomaterials for Humidity Sensor Application. So basically, nanotechnology become very important in our daily life because it has been used in various fields, including sensors, electronic devices, battery, and so on. Basically, nanotechnology is seeing exponential growth in many fields and is predicted to have robust future developments. We can tune the size and shape of nanometals so that it can be used in novel application to give different properties. And we can see nanotechnology give significant lifestyle transformation with the progress of nanometal research and application. So for electronic industry, basically nanotechnology has been with us for almost 70 years. We can see nanometals and nanotechnology have many applications in every field of science and engineering, which lead to greater technological advancement. For example, we can achieve better conversion sunlight of efficiencies when we have nanomaterials incorporated into solar panels. Additionally, we can see that monitoring health with tiny sensors allows more comfortable and personalized treatment for patients. And we can use nanometals in other applications for example, in pollution control and wastewater treatment, which make our water accessible to all. Then we can see that nanometals is also important in batteries. We show that by having these nanometals inside the battery, we can have greater energy storage. And nanotechnology also enables the packing of foods with a longer shelf life and improved freshness. So recently, emerging technologies domain such as smart surfaces and IoT demands a new generation of electronic materials which combine small dimension, sustainability, and comprehensive range of properties, which include optoelectronics, energy harvesting, and sensors. So in this case, metal oxide nanostructures have been revealed as particularly promising for this application because it shows good electrical and optical properties. It has a capability for transparency. It can be produced in large area, and it has good mechanical flexibility while also enabling integration in nanoscale devices. And the properties of metal oxide basically can be tuned in form of different morphologies, therefore make it possible for various applications. Having in mind the environmental issue the world is facing, preference should be given to low-cost and sustainable materials and approaches that can still provide high integration levels and performance. And we believe metal oxide materials, for example, zinc oxide, titanium dioxide, could demonstrate the multifunctionality desire to meet these requirements for new electronic concepts, such as smart surfaces and humidity sensors. So in this research, basically, we want to highlight on humidity sensors, the application of nanostructures, metal oxide nanostructures for humidity sensor application. And before we proceed, we should understand what is humidity sensor is. So basically, it's a device that detects changes of humidity level and convert it into a signal. So any signal could be converted based on humidity in environment. So the signal can be in form of electrical, optical, and structural change. And basically, the sensor response is determined as relative change in a major physical parameters such as resistance or current, capacitance, power gain, or resonant frequency value of the devices with respect of time. There are few types of humidity sensors in the market now, but the most popular one are the resistive type and also capacitive type. The difference between these two is basically the signal that they produce by these sensors. Basically, for resistive type, when it exposed to different humidity levels, their resistance will change. While for capacitive type, basically the capacitance value of the sensors will change with the different level of humidity. And this type of humidity sensors is best suited and most popular ones in advanced application such as lab research and automated industries. It also has simpler structure, free choice of sensing elements among various available types, cost-effective adaptability to different types of circuits, and ease of fabrication and measurement setup. So there are many applications of humidity sensors. So basically, humidity sensors is necessary in these industries: food processing, chemical or pharmaceutical storage, industrial process control, biomedical, agriculture, aerospace, structural health monitoring, indoor climate control, and etc. So this is why we need to have very good humidity sensors, because we want to get the optimum humidity level for our life. Because at high relative humidity, basically it can cause damage in our home or office. It can increase the off-gassing of VOCs, which is often carcinogenic from a variety of consumer products. And if the relative humidity above 70% RH, we can have this small foggy windows, condensation, and warping of wooden object. And when we have this relative humidity and temperature are too high, basically we as occupants tend to feel more uncomfortable as their ability to lose heat through perspiration is reduced and we sweat a lot. And it can produce other problems and decrease the stability of orders. And we can see that if we have too much moisture, it can lead to mold and overheating. Too little of RH value will cause dry eyes, chapped lips, and environment in which bacteria and viruses can thrive. Therefore, this is the optimum RH value that we need for our healthy condition. So basically, it's in range between 40 and 60% RH. So in sensor application, particularly for metal oxide based humidity sensors, so after we fabricate it, there are a few methods to characterize. We can use a SAT solution to induce different level of humidities. For example, we can use LiCl here to produce 11% RH, and we can use potassium nitrate to induce 95% RH. And we can measure the change of signal based on this solution, SAT solution. Another method is by using humidity chamber. So in our lab, we basically use humidity chambers. So this aspect 261, and then we use the measurement system of Gatley 2400 to measure the signal that produced by our fabricated humidity sensors. And inside this humidity chamber, the RH was varied in a stepwise manner, and the increment of the sensor current were measured in situ using a digital measurement system. So basically, this how we measure our samples. We have two probe here, and we have a contact which connect with the probe and also the measurement system. And this is our sample. And after the measurement, we basically produce this plot. So this is basically the current signal at initial level, and this is the current signal at higher or high humidity levels. So we can change this humidity level automatically by using humidity chamber. So based on this result, we calculate the sensitivity value of the sensors by using the resistance value at initial stage and also at specific humidity level. So these are basically the mechanism of humidity sensors. So basically there are three mechanisms involved in humidity sensor. The first one is based on electronic conduction. When we have more water molecules, it will chemisorb on the film surface, and therefore more electron will be released. Because when we expose our sensors in environment, the oxygen tend to absorb on the surface, and it will trap the free electron here. And when the humidity comes and absorb on the surface, so basically it will release the electron that trap in this absorbed oxygen ion. So this electron will improve the conductivity of the film and produce current signal. And normally it happens at low humidity level. At high humidity level, basically the ionic conduction will take place. So this often called as Grotius chain. So what happened here is that the hydrogen ions bonding with the water molecules to form hydronium ions, which then release hydrogen ion to their neighbor water molecules, causing a continuous hopping among consecutive water molecules. If we have more water molecules, there will be more proton hopping and the film become more conductive. And normally it happens in this top layer, the proton hopping, and this involves the movement of an ion from one side to another side through defect in the crystal lattice. So this is often called as Grott's chain. At very high energy level, for example, close to 100% RH, electrolytic conduction probably happen here. So what happens is that the water molecules will condense between the nanoparticles or nanomaterials, and we can have more hydronium ion movement and the film become more conductive. So there are few strategies to improve metal oxide based multi-sensors. We can use doping process to improve carrier concentration. We can use dense and small size nanostructures, which can enhance the surface area of nanostructures. We can use surface treatment, for example, annealing process, plasma treatment, and this process basically can improve the surface condition and crystallinity of the materials, of the sensing materials. We can also can functionalize the surface hydrophilicity of the material so that it can absorb more water molecules on the surface and produce better signals. And we can have a coating process, for example, polyvinyl alcohol, tin oxide nanoparticles, which can produce small pores, and some of the coating is the water molecule absorbing materials, which can attract more water molecules and produce better signals. So in our research, we fabricate a few metal oxide. For example, in this case, for zinc oxide nanostructures, we use sonicated soldier emission process, whereby we use sonication ultrasonic water bath to produce homogeneous solution, and this solution we use in immersion process to produce zinc oxide nanostructures. So these are the results of what we have optimized in our lab. So we basically optimize doping process based on tin ion. We varies the tin ion from 0 to 3 atomic percent, and from this optimization we can have at 1 atomic percent of tin concentration, the sensitivity of the sensors produce the highest value, the sensitivity value of around 3.72%. So this basically come from this plot, okay, from the measurement system, from the humidity chamber and the measurement system, and we can see this is the plot of 1 atomic percent tin dope zinc oxide non-arrays humidity sensors. And when we evaluate why the sample that doped with 1 atomic percent show the highest sensitivity is because of few factors. One is the porosity induced inside the sample itself is better compared to undoped zinc oxides and other samples, and also their structural properties in form of stress. We can see that the stress induced in tin doped zinc oxide nanoarrays at 1 atomic percent show the lowest compared to other samples. So the doping process is very important to improve the sensor signal, because based on doping process, for example, in this tin doped zinc oxide nanorods, it can induce extra electrons here, and this extra electron can bind with more water molecules, and then it can affect the current signal on the sensor surface. So we have measured the current voltage properties of different samples based on different doping concentration, and we have this plot here, and we can see that 1 atomic percent dope sample show the highest current value, and it shows highest conductivity value compared to other samples. in order to improve further the sensing performance, we coat thin oxide nanoparticles on the thin doped zinc oxide nanoarrays for the sensor application. So we varies the time of coating process from 1 minute until 50 minutes. And from this optimization, we managed to get the highest sensitivity at 6.28 for the coating process at 5 minutes. So when we observe through FESM or field emission scanning electron microscopy image, we can see that after the coating process with 5-minute thin oxide nanoparticles, it produces a very rough surface on the top surface, and we can see that there are small pores channel are observed on the surfaces. So it actually provide more water absorption sites and will enhance capillarity effect so that it can improve the sensing performance. And we characterize with AFM measurement as well, and we observe that the coated sample with the thin oxide nanoparticles has higher surface roughness compared to uncoated sample. And from the coating process, basically when we anneal it at 500 degrees Celsius, so some of the thin ion from the thin oxide nanoparticles diffuse into the zinc oxide nanoarrays and produce the dopant ion. So it improves actually the carrier concentration of the films. So you can see from the Hall effect measurement here, when we coat the sample with 5 minutes thin oxide nanoparticles, the carrier concentration improved to 1.8 multiplied with 10 to the power of 19 cm minus 3. So we can see the improvement of carrier concentration after we coat with the thin oxide nanoparticles. And we also produce humidity sensors based on titanium dioxide nanostructures. Basically, it's based on this experience, whereby previously we have coated titanium dioxide on FTO substrates. But the problem with this FTO substrate, when we measure using the humidity sensors measurement system, it's very difficult to get the sensing signal because of the leakage current. So what happened here is that the probes, because this thin oxide layer is too thin, when we coat with metal contact, the metal contact particle here tend to diffuse into thin oxide to the titanium dioxide layer, and it therefore produce the short circuit here. And when we measure, it's basically we measure direct contact between the metal contact and FTO, not the titanium dioxide signal after exposure with the humidity levels. So to replace the FTO layer, we need to deposit seed layer of TiO2 so that it can assist the growth of titanium dioxide nanostructures on the substrates. So what we have here is that we use a sputtering process to produce a sputtered titanium dioxide layers, and this will be used in deposition of titanium dioxide nanostructures by using solution process. So this is what we have after immersion process from 1 hour to 5 hours. So this is photo image of the samples. So you can see that at 4 hours immersion process, we produce very uniform film here. And when we observe through FESM, we can see that the nanostructures exist on these samples with the shape of nanoflowers. And we confirm the characteristic of this film by using X-ray diffraction measurement. We can see that all samples actually are in tetragonal rutile phase titanium dioxide layer. And this is a humidity sensing measurement plot for the sample of titanium dioxide nanoflowers at different emission process. At 4 hours, it basically produced the highest sensitivity value of 196. And in terms of their stability, when measured at various cycles, it produced almost a similar plot, which suggests that this layer actually produce a very good sensitivity value with high stability. At 4 hours, titanium nanostructures, it basically produced the best performance because it has the highest density of titanium flower nanorods, which can absorb more water molecules and makes it more sensitive compared to other samples. We also fabricate nickel oxide-based humidity sensors by drawing nickel oxide nanostructures on the glass substrates. So previously, basically to grow nickel oxide nanostructures, we need the conductive coated glass substrate to assist the growth of nickel oxide nanostructures. But in this study, in this research, we use a nickel oxide seed layer to assist the growth of nickel oxide nanostructures. So this is the process that we use to fabricate nickel oxide nanostructures. Use low-cost immersion process, solution immersion process, as we use in zinc oxide nanorays fabrication. So this is a nickel oxide nanostructures that produced on the substrate after the immersion process at different immersion time. So we can see that the nanoballs produced on the substrates for 1 hour, 2 hours until 3 hours. But the difference is the density of the nanoballs here. So you can see that the plot of sensitivity, the plot of humidity sensing measurement show that when we have nanoball at 2 hour immersion process, it's basically produce the highest sensitivity value of 169. And you can see based on different immersion process, we have different thicknesses of nanoballs films on the substrate. For 1 hour, we produce 8.8 micrometer. For 2 hours, 16. While 3 hours, we produce 20 micron thick film. So when we characterize the sample using transmission electron microscopy, so we can see that this nanoball actually consists of few layers of nanosheets that has very high porosity on the surface. So you can see that this is a porous area that able to absorb more water molecules and enhance the performance of humidity sensors. And in terms of stability, when we measure at different cycle, so it produces almost similar plot here, as well as we measure in different humidity levels from 50% RH, 60 until 90% RH. It produces a good response for every humidity levels. As a conclusion, we will say that the metal oxide nanostructures could be fabricated using a simple solution immersion method at low temperature below 150 degrees Celsius. And these metal oxide nanostructures show promising results for humidity sensing with high sensitivity. And we can improve the performance of the sensors by using doping process and modification of the surface structure and shape. So with that, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.